Okay, now we're doing a completely different math. We're going to be working with matrices, doing operations for matrices. And matrices, where they're used in life, any type of search engine. So think about an Excel spreadsheet, right? So in each cell, you have some type of information, right? Well, matrices are built kind of on that idea. All right. So one of the rules for combining like terms, which means adding or subtracting matrices, they have to be alike. Just like everywhere else in math, if you are doing money, you have to add the same place value. So if you added 25 cents, you would be adding like terms. You would not add 25 cents like that. So everywhere in math, when you're adding like terms, you cannot add 3x plus 2y, but you are able to add 3x plus 2x because they're the same term. Okay, so what you have to do with matrices is you have to name, identify their size, and you always list it rows. In fact, you can do it lowercase r, rows by columns. So 1, 2, 3 rows by 2 columns. So this is a 3 by 2. 1, 2, 3, 3 rows. And if their size is the same, then you can go ahead and add. So we're going to, then this is going to be a 3 by 2. I'm going to leave some space because I'm going to show the adding later. You won't have to do this. But so the exact same location in the matrix, each matrix. So for this one, we're going to add -4 plus 3. And for the right columns, this would be 0 plus 6. So I'm going to just keep doing that all the way down. We have -4 plus 2, 0 plus -6. Then we have -2 plus -6. I'm going to go ahead and underline those. Then we have -5 plus 5. So when we finish, we have a 3 by 2. -4 plus 3, -1. 0 plus 6, 6. -4 plus 2, 0 plus -6. -2 plus -6, -8. -5 plus 5, 0. So this is the sum matrix. So we come over here, same thing. This is a 1 row by 4 columns. This is a 1 row by 4 columns. So the answer will be 1 row by 4 columns. And I'm just going to let you, so -2 plus 1, -1, -1 plus -6, -7. I'm just going to do it different colors. -4 plus -3, -7, and then 3 plus -3, 0. And this is also 1 row by 4 columns. And that's the sum matrix. Okay, so now the next thing that we're going to do is, it looks very much like the distributive. This is called scalar multiplication. What that means is this is scaled 4 times larger. The number that's being multiplied just scales, kind of like if you were to, on a piece of paper, just somehow turn a piece of paper into a kite. You thought, oh man, I want to send this to a company and I want to actually make an actual kite. That means we scale it up. That's what scalar means, is you're enlarging it how many times? By a scale factor of 4. So you're going to treat it like the distributive. So this is a 3 column at 3 rows by 2 columns. So the answer will be, and I'm going to show the multiplication. So this is 4 times 2, 4 times 6, 4 times -1, 4 times 6. I'm going to get sick of saying 4 times 6. I'm combining the parentheses with the 6. All right. So the product will be a 3 by 2, 3 rows by 2 columns. 4 times 2 is 8. 4 times 6 is 24. 4 times -1 is -4. 4 times 6 is 24. And the rest of these are 4 times 6. So I showed you how to do the scalar multiplication. You don't have to do this step. I was just showing you it's just like doing the distributive to each of those. So you can go from this one to that one on future ones. All right, I'm going to do a separate video for matrix multiplication that's more complex.